to all the viewers in today's live and interactive session of class 8th on Avidya channel number 8 and along with on our official YouTube handles. These are NCERT official and NCERT PM Avidya class 8 YouTube channel. My name is Rajan Rajput and here we are joined by sign language interpreter Neetu. Neetu, warm welcome. For class 8 student, we are going to learn chapter number 9 from your science textbooks. And topic is the amazing world of solutes, solvents and solutions. So this is going to be very interesting. And if you have any query and doubt regarding this topic, we have various medium to connect with us. First, note down our IVRS number that is also flashing on your screen, and number is 8800440559. Also, you can write us mail on the dedicated mail ID for class 8 students, and ID is dth.class8@ciet.nic.in. Viewers who are watching this live interactive session on official YouTube channel NCERT official, so live chat box option is available to drop your comment and queries. Without any further delay, let's welcome our today's guest. Here we are joined by Ma'am, Miss Priti Maan, TGT is from science topic, and we are here from Bharati Public School, GRH Marg. Ma'am, thank you so much to here with us. Warm welcome.
Thank you.
So ma'am, what are the overall learning outcome for this session and what we are going to learn in today's session?
Okay, so this chapter is basically the carry forward of chapter 8. Wherein we have studied something about what are the mixtures, how are they prepared, what all stuff is required to prepare a mixture. So we have seen that mixtures are of two types. They are homogeneous mixtures and heterogeneous mixtures, right? In this chapter, we'll be studying more about that when we are preparing a mixture. When we say that based on its composition, whether it is uniform and or non-uniform. So as we go with the name of the chapter, the amazing world of solute, solvent and solution. So we'll be discussing more about these terms also. So we'll quickly start with the chapter. So as we have these terms, solute, solvent and solution, right? So these are what? These are the three key players when we make any sort of mixture. So individually we'll see what these terms are. So first we talk about solute. What is a solute? It is that solid that gets dissolved. So while preparing say salt solution or sugar solution, right, what do we take? We take a solid, that is a salt or sugar. Next we have solvent. Solvent is that liquid in which the solute or the solid substance get mixed, and water is considered to be a universal solvent. Now next is, what is a solution? Solution is what? It's a uniform mixture wherein a solute is evenly distributed in the solvent, right? Now we'll see it that how a solution is prepared. Okay, so we have these solutes with us. And then we have water. So if you are able to see, we have two solutes present in here. This is salt and this is sugar crystal, and when we add water to it, now if we want to prepare a solution, what do we simply do? We either take salt or we take sugar and just take little amount of solute and dissolve it in a solvent, right? And we know that both sugar and salt, they are soluble in water. So as a result, what we get? We get a solution, right? If that's visible. So it is a clear solution, okay, which has solute, which is salt, and solvent, that is water. So these are called as what? Components of a solution.
Okay.
Always a solution is made when it has a solute and a solvent present in it, right? Now further we move that air is also what? We have seen that air is a mixture of various gases.
Yes.
Okay, and the composition of nitrogen is a lot in it. 78% of nitrogen is present and 21% of oxygen is present. So we can, in that term, we can say that nitrogen acts as what? A solvent. Oxygen and other gases, they act as what? Solutes, when this uniform mixture is being prepared. Now one more term there is given, that is uniform. So what exactly it means when we say that something is having uniform composition. Now if you see this mixture here, right, this solution if we talk of, so this solution, can you say that what is mixed in this?
No.
No. Why? Because the salt crystals, they got evenly distributed. Same thing would have happened if I have taken sugar. Right, sugar also, because the particles are soluble, the particles dissolve and they go into the empty spaces of water. That's
But
the reason.
sometime it takes time.
Yes, sometime it takes time. Now that is the factors that depends over there.
Okay.
So when we'll see that later in the chapter, that depends on temperature.
Okay.
Yes. So in this case, we have seen what uniform mixture means, that wherein the salt or sugar, they are completely dissolved in the solvent. Okay. Now coming up next
Yes.
is what?
Types of solutions. So what are the types of solutions, ma'am, we have?
Yes, we have these saturated and unsaturated two terms given in here. Now saturated means what? We call it as hungry water, right? That's a funny term that we have used in here, but yes. Now saturated solution is the one wherein we can add more of, say, solute into it, right? Now if I take example of this same beaker over here, right, we have added some amount of solute,
Okay. Yes.
right? So what
right.
I can do, I can still add more of solute to it. I can keep on adding till the time all the empty spaces of liquids get filled. Yes?
Yes.
So we have seen that why the soluble solid dissolves in water, because there are empty spaces present, right? And the soluble solid is taking that position in those empty spaces, but there is a capacity.
Okay.
In this
Right,
beaker, I can say I can dissolve 10 spatulas. Okay. More than that, if I try, then what will happen? It will not get dissolved, it will settle down at the bottom. So earlier the water was what? The water was hungry.
Yes.
Right? So we can add more of solute to it. Now see, we have added the solute, and if that's really visible to you, there is a layer of solute right at the bottom.
Yes, ma'am.
Now why is that layer formed? Because we have crossed the capacity of water in over here, right? Whatever were the empty spaces present in water, now they are full. So where the solute goes, it settles down at the bottom. So when this position is reached wherein the solute is settling down at the bottom, we call the solution as saturated solution. Right?
Clear,
so
ma'am.
saturated
Yes.
solution is what? It is full water. If we are saying unsaturated solution as hungry water, wherein we can add more of solute, so unsaturated solution, will call it as full water. Now no more solute can be added. There are certain factors using which we can turn a saturated solution unsaturated. Again, that is temperature dependent. Okay. Before reaching up to that, we'll just quickly take up one more type, as you have asked that what are the different types. So that covers here one more example to it, that is dilute versus concentrated solution. Now that completely depends on what? How much amount of solute is added. Now we have these crystals over here. See, these are the crystals of potassium permanganate, right? And these are the crystals of copper sulfate. So we can pick either of it. So the crystals are beautiful in color. That's why I brought both of these.
Okay.
So I just love the colors of these crystals, right? So this one is what? Copper sulfate, and this is potassium permanganate. And what we are talking about, what do we mean by dilute and concentrated solutions? Okay.
Okay, ma'am.
Now we say that we are preparing a solution. All right. Now the amount of solute, we didn't say that how much amount of solute is required. So say if okay, I'll take the another one. So if I take just a spoon full of these crystals, you see the color of,
That's beautiful, purple.
yes, right. So I have taken 3 spoons of the crystals and I have dissolved, right. The color is visible.
Yes, ma'am.
It's very dark. Now the other case, what I am doing, I am just taking, I am not even using the spoon, just 2-3 crystals I have dropped, right, few more because the color is not coming. Okay, here also. So in both the cases, what I did, I prepared a solution, right, and in both the cases the solute is what, potassium permanganate, and the solvent is what, water.
Water.
But still there is a difference in these two. The difference lies in their concentration, that how much amount of solute I have taken. Okay.
Okay.
So this one, this is what, dilute solution of potassium permanganate in water, and this is what, concentrated solution of potassium permanganate in water, right?
Yes.
So even see, when we prepare lemonade, so what happens in that case? If by chance we add more of salt or more of lemon, what do? We add more water to it.
Yes,
Right?
ma'am. Right.
So why do we add more water to it? We make it dilute. Earlier it was concentrated, so by adding more of water, what exactly we do? We make it dilute. Same thing applies with the squashes also. Kisan fruit squash and some other fruit squashes which are available in the market. So how do we prepare? We have a concentrate formula of it, right? We take it and we dissolve it in water.
Okay.
Right?
Right.
So that is how the solutions, they vary depending on the concentration. They are either dilute solutions or concentrated solutions. That completely depend on how much amount of solute we have added to it. Now next is, what is this term called as? Now that is what? Solubility, right? Right now just what I did, I took some amount of solute and added it into the solution, right? So the amount of solute that is dissolved in a given amount of solvent, this is defined as what? Solubility.
Okay. Yes. So, ma'am, are there any factors on which solubility depends?
Yes. Now see, we are adding a solute into a solvent.
Yes.
Right. And earlier 2 examples I have told you what, that yes, temperature plays a very important role here. So solubility does depend on what? Temperature.
Okay.
Right. We did
Right.
talk of dissolving, say, salt in water, sugar in water. But have you ever seen that sugar doesn't dissolve so well with cold water?
Yes.
While preparing lemonade also, we first mix sugar with normal water and then add cold water to it. Now
Right,
why this is done? Because the sugar won't be dissolving perfectly in cold water. Right? So temperature plays an important role. So that's what is the first factor. Heat it up, right? You increase the temperature, what will happen? The solubility will increase. So these are directly proportional to each other. Increase temperature. Now what will happen? The solvent will have spaces between them and you can add more of solute to it. Okay. Next is, so that is temperature dependent. So once you are increasing the temperature, the solubility is increasing on its own. Now next, what is happening? That by increasing temperature, we can make a saturated solution unsaturated, right? We have seen what is a saturated solution. It is the one wherein we cannot add more of solute.
Okay.
Right? So because all the spaces are filled, so the solute has taken all the spaces which are present in the water. That's the reason why the solution has become saturated solution, right? Now how we can turn a saturated solution unsaturated? So the same case. Now lemonade, in our lemonade we have more of lemon juice. It is, yes, or more of say salt, and it's not tasty. What do? We add more of water to it, Yes. So adding more of water, what exactly we have done? We have increased the amount of solvent. So the particles will get distributed now. Yes. And second thing, what we can do, not with the lemonade in general cases, we can do what? We can increase the temperature. Now what exactly is happening? We have seen that solubility, it is directly dependent on temperature. So as the temperature rises, yes, the particles gain that energy. After gaining the energy, they start to move. Okay. When they move, so they create spaces between them. And as a result of it, the spaces have been created, you can add more of solute to it. So these are the two ways due to using which we can convert a saturated solution into unsaturated one. Again, I am saying because we are learning these terms for the first time. Saturated solution was the full water that you cannot add anything into it, that type of solution. And unsaturated solutions, they were hungry water, that yes, you can add more of solute to it, right? So by increasing the temperature or by adding more of solute, what we can do, we can make full water to hungry water.
Okay. Yes, clear.
Now next we have solubility of gases, right? We have seen that dissolving sugar in water or dissolving salt in water, what exactly we did? Sugar is in solid state.
Yes.
Solid was dissolved in liquid. Same with the potassium permanganate crystals also, the beautiful colored solution that we have prepared. What exactly we have dissolved? We have dissolved again solid in liquid. Right. Now what about gases? We even have seen that solubility, if we want to increase, what we have to do? You have to increase the temperature.
Okay.
Right. But with gases, it is just opposite. If you increase the temperature, what will happen? The solubility of the gas, it decreases. Now that's the most common thing that we have seen in our houses. While we boil water, right? On boiling water, what exactly happens? You see those fumes, vapors coming out.
Right.
So what are those vapors? They are exactly the dissolved gas. Right. There used to be a question when I was, I think, in grade 9 or 10 that you have boiled the water, right? You have two conditions.
Yes.
First condition, you are keeping the fishes at room temperature water, and second condition, you have boiled the water and now you are keeping the fishes in that when the water comes at room temperature. In which case the fishes will survive. Right. Obviously in the first case, because in second case when we are boiling the water and then cooling it down to the room temperature, what exactly has happened? Whatever were the dissolved gases, those gases, what they got evaporated. Right. So the same thing happens in here also. When we increase the temperature of a liquid, whatever gases are dissolved in it, right, those gases, they just vaporize. Right?
Right.
So the solubility of gases, it decreases. You can see here cold water, it retains higher concentration of dissolved oxygen, making it ideal for fish, because I took that example. I really like that question, that's why ideal for fish. And hot water, what exactly happens in there? Now gases are released, so you will not be having the same amount of oxygen which is present in cold water than in hot water. Now this is the graph that is given. So if you see it, this is a solubility versus temperature graph, right? Now if you see, as the temperature increases, now here it was 0 degrees Celsius to 10 degree, 20, 30 degree. Right?
Yes.
And the solubility, what is happening? The curve is going downwards here.
Yes.
So what does this indicate? That what happens to the solubility when the temperature increases, the solubility of the gas, it decreases. Right?
Okay.
So this happens with the gases. Now next is that whatever substance which are there, now we had talked of liquid, so what happens? The object either floats or it sinks, right? Now, why exactly is that happening? Why some objects are floating and some are sinking? We did talk about buoyancy, we did talk about buoyant force, but is that applicable in all the cases? Right? So, sometimes we see that a tiny pebble, tiny stone, it goes straight down in the water, but a big wooden log, it floats on water. Why that happens? Now, this is because of density.
Okay.
Right?
So
density of,
yes. What is density, ma'am?
yes. Now, density is what? Now, that's how we calculate it. That scientifically we say that what? That density is mass present in a unit volume. Okay. So, the formula is easy, but to understand it, it takes us a bit of time. That first you need to know what is mass. Right. So, whatever is the matter which is present inside us is mass. It is calculated in kilograms, and volume is, it is calculated in meter cubes or centimeter cubes. SI unit to it is meter cubes.
Okay.
Right. So, the total SI unit for density becomes kg per meter cube. Now, based on the density, see, water has its own density.
Yes.
Right. So, if an object is having more density than that of water,
Okay.
what will happen to it? It will sink in water. Right?
Yes, ma'am. Right.
Like in this case, the key, it got sinked, it is right at the bottom of this glass, right? This key here.
Yes.
Because it has got the highest density. Now, we see that apple is floating somewhere in the middle, right? Because it is having density that is somewhere equal to water, right?
Right.
And the one that floats right at the top. So, why it is floating right at the top? Because this toy is having density which is less than water. Okay?
Yes,
so,
ma'am,
that's
clear.
how it is dependent. Now, next is that.
So, ma'am, yes, next my question is that what factors does this depends on?
Yes. So, temperature and pressure has their own variations over density. So, we have seen that density is what it is, formula wise, if we see that it is mass upon volume, right. So, quickly we will explain this also. This is mass and that's volume. And these are what? These are, volume is completely dependent on what? Temperature, right. So, what happens in here, when we heat any substance, okay, on heating what happens? The substance expands, same
Yes.
happens with water also, the particles they expands, volume increases. Okay, that is happening when we talk of temperature. Now,
Okay.
coming back to the formula over here, if volume increases, what will happen to the density? It will decrease.
Okay.
Because they are inversely proportional to each other.
Clear, ma'am.
Okay, on increasing temperature, what is happening? Volume, it increases, that in turn decrease the density. Now, going back to this slide, what happens when pressure is getting affected over there? So, when gases are compressed, right? So, volume decreases. So, gas, see, in this room, the room is filled with some gas.
Yes.
Right. If I take up all the gas and fill it in a balloon, now what exactly will happen? The volume will decrease.
Yes.
As of now, the air is, the gas, whatever, say oxygen or nitrogen, it is completely filled in this room. It is covering this much of volume. So, once I fill that in the balloon, what I have done? I have reduced the volume.
Yes.
Yes. How I have reduced the volume? By putting some pressure.
Right. Yes.
To bring all these particles close together, what exactly I need to do? I need to increase the pressure. So, when pressure increases, volume decreases. Now, coming back to the formula again, right? Now, when volume is decreasing, what will happen to the density? Density will increase.
Clear,
Right? So,
ma'am.
this
Yes.
volume depend on temperature and pressure. So, that is how they are related to each other. Now, this chapter has got very good numericals. Students should check out those numericals. So the formula remains the same only. Density you have to calculate, mass and volume should be there. What we need to check? We need to check for their values, what units it is given in.
Okay,
So
ma'am.
if it is
Clear.
say in grams, you need to convert it into kgs. If it is in centimeters, you need to convert it into meters. That needs to be kept in consideration, and
Okay,
rest
ma'am.
you can do the numericals very easily.
Clear, ma'am. Thank you so much to explain this whole chapter in a very interesting manner. We are with ma'am Priti Maan, TGT of Science subject. Ma'am, thank you so much.
Thank you.
Here we are using some name of some products. Just for example, we are not promoting any of them. Time to wrap up the show, and here we are with the next program at 3:30, and topic for that session is mathematics. Topic is linear equations in one variable. Thank you to interpret this whole session, Neetu. My name is Trajan Rajput. Please join with us with next program. Thank you so much.